All right, so here's where we are. So we have 12.3 and 13.2 left. I've decided I'm going to do some of each. So I'm going to do an incomplete job on 12.3 and an incomplete job on 13.2, but hopefully give you enough to get you started on that. Okay, if I waited until Tuesday to introduce 13.2, then you'd only have 2 days to look at it before the test. Okay, instead, I'll give you enough of 12.3 to get you started, and I'll show you enough of 13.2 so that in theory at least, you have 1 week to digest all this material. Okay, so again, I'm going to choose to do an incomplete job with 12.3 and an incomplete job with 13.2, but give you enough to get you going. And then Tuesday, I'll do likewise. I'll do finish up the loose ends from 12.3 and likewise for 13.2. But I thought it's better if I show you some of 13.2 now, so you have a whole week to look at it rather than just only having 2 days over here. Okay. All right, and then when I think I've done enough, then I'll go ahead and give you today's quiz. Okay, so I'm kind of doing a little bit of 12.3 and also 13.2. Okay, so I'll do some of 12.3, an incomplete job, but enough to get you started. And then I'll start some of 13.2, also an incomplete job, but at least you've seen how they work. Okay? And then the remaining days, so our last regular exam is next Thursday. You know what that's all about. Tuesday, you say, what's happening? I'll let you ask review questions for the final. And the best way to review, again, is the old exams. So just whip out the old exams. And on Tuesday the 15th, you can ask me questions from previous exams. That's the best way to study for the final. And then we take the final exam on the 17th, and then that's it. We're all done with the course, okay? So that's what's happening. All right, so I'm going to go straight to doing some problems from 12.3, some problems from 13.2, and then when I think I've done enough, then quiz time. All right. All right.
Mr. Holmes, and on that final is how many questions on that final?
I'm sorry, say that again, Orlando.
How many questions on your final?
How many questions on the final exam? Okay, I haven't decided, but it's probably going to be more than what I typically give you. So what do I typically give you is 10. So 15, 20, something like that is what I'm leaning toward. Well, I can't give you too much because you still only have an hour, 15 minutes. So maybe 15 is what I'm leaning toward.
And it'll be like an average of each chapter you covered, or?
The most likely scenario, I think, if I give you 15 questions and we're going to have 5 tests, so maybe 3 questions from each exam. It doesn't have to be the very same question, but similar to that.
Okay, so it'll be based off the exams, for example.
Based just off the exams, right. So in other words, don't go back and study everything, quote unquote. That's too difficult. Right. I've narrowed it down to just studying the 5 exams, 4 of which you already have. So it wouldn't be a bad idea to whip out the old exams and start reviewing them. And then, of course, we're about to get the 5th exam next week. And just study that for the final exam, okay?
Okay, thank you.
That makes it much better than saying study everything, right? You can't study everything. I can't study everything, right? So I've narrowed it down considerably, okay?
All right.
Okay, so here we go. So 12.3 key concepts that I just mentioned last time is the integral of e to the x is itself e to the x. And the integral of 1 over x is natural log absolute value of x plus a constant. Okay, and so now we're going to do a bunch of problems involving that. So here we go. All right. And again, don't be surprised if my questions don't match your questions. Doesn't matter. We're still learning the material, right? All right, so 12.3. So my problem 2 has the integral of 4e to the 4x dx. Let me put the book down because it's heavy. All right, 4e to the 4x dx. Now, what is the derivative of 4x? It's 4. Perfect, it's already there. Okay, so that u equal 4x. du is 4 dx. Okay. As you might anticipate, the beginning problems are easier than the ones at the end. Okay, so this becomes e to the u. Since I'm going to change u to 4x, and I'll substitute 4 dx. Again, don't say, oh, they're not together. It doesn't matter. You can pick up the 4 and move it there. That's my du. So I'm going to integrate e to the u du. So we're doing substitution just like last time. What's the integral of e to the u? Itself. So e to the u plus c. And the last step is to change u back to what it was. What was it? 4x. So final answer, e to the 4x plus c. And by the way, that's very easy to check. What is the derivative of e to the 4x plus c? Well, of course, plus c. C is any constant, so its derivative is 0. What's the derivative of e to the 4x? It's e to the 4x, and then by the chain rule times 4. Well, perfect. There it is, 4 e to the 4x. Okay, so it works. All right. Now for problem 4, again, more accurately, my number 4, I don't know if it matches yours or not. Okay, so it has e to the 2x. If I substitute u equals 2x, what's the derivative of 2x? 2. This problem doesn't have a 2, but you should know by now from last time what the game is. Go ahead and put in a 2, as long as outside I put 1/2. Okay, so u equals 2x. So the next step, instead of writing e to the 2x, I'm going to write e to the u. Okay. But the derivative of 2x is 2. So du equals 2 dx. So again, I cannot substitute for du until I see 2 dx. So I just put in the 2 and half outside. You can do that for constants, but not for variables. Okay, so now the next step, e to the 2x is going to change to e to the u. And 2 dx becomes du. But there's a half outside. Okay, but at least I got this the way I want it to be, e to the u. And what's the integral of e to the u? E to the u plus c, except there's a half out in front. Okay, and the last step is always to change u back to what it was. It was originally 2x. So 1/2 e to the 2x plus c, final answer. And yes, you can check that by differentiation. What's the derivative of this? Okay, the derivative of 1/2 e to the 2x is 1/2 e to the 2x. And then by the chain rule times 2. Well, times 2, that 2 will knock out that 1/2, and you'll just be left with e to the 2x. So it works. And of course, the derivative of any constant is 0, so that's never an issue.
Professor Hong, can
Yes.
I interrupt? How come the number 2 you did not multiply by 1/4?
How come I didn't have to multiply by 1/4 over here? The
Yeah.
original problem already gave me the 4.
Oh,
Okay. Now, if the original problem was like this, if that's what you mean, then yes, I would have to multiply by 4 and then the 1/4. But they already gave me the 4. It was perfect because the derivative of 4x is 4. It's already there, so I didn't have to worry about that. I did have to worry about it in question 4. And I'll have to worry about that in question 8, it looks like also. Okay.
okay.
Right. So the original problem has 250 e to the negative 0.5x dx. Okay, I'm pretty sure that 250 doesn't have anything to do with, this stuff. So I take the 250 out. But I want to change negative 0.5x to u. So let u be negative 0.5x. And then du is negative 0.5 dx. Okay. So yes, we did not have a negative 0.5. So the remedy is put in negative 0.5 and outside 1 over negative 0.5 in red. Okay, so outside I have 250 times 1 over negative 0.5. You can punch that in your calculator. It comes out to be negative 500. Okay, so 250 times 1 over negative 0.5, negative 500. E to that mess is now e to the u. It's as if to say, I don't care what mess you have up there, I'll call it u. I'd rather work with e to the u than e to something complicated. And then negative 0.5 dx, negative 0.5 dx, that's my du. Okay, again, multiplication is commutative. You can change the order anytime you want. So don't think, oh, the negative 0.5 has to be for this. No, it can be before or after. And I know how to integrate that. So it's negative 500 integral of e to the u. And the integral of e to the u is e to the u. So negative 500 e to the u plus c. And then just change u back to what it was. It was negative 0.5x. So final answer is negative 500 e to the negative 0.5x plus a constant. Right. So it looks like in general, most of the time, I'm not going to say always, but most of the time, when you see e to something complicated, let u be that complicated thing. Because instead of doing e to the whatever, it's going to be e to the u. Right? The next few problems, it's e to something even more complicated, but whatever, e to whatever, let u be that exponent is almost always going to be the way to do these problems right now, okay? So yeah, now it gets more complicated. With number 10, and again, this is my number 10, it may not be yours, but whatever. Okay, so the original was x e to the 2x squared dx. So it's almost like this. I don't like e to the 2x squared. I like e to the u, right? So it's almost like saying, no matter how complicated a mess this is, it can have 2x squared minus 5x plus 7 or whatever. Just let that be u. And then later, I'll just be integrating e to the u instead of e to the whatever mess it was. Okay? So it's almost like saying, whatever is the exponent, call that u. So u equals 2x squared. And what is the derivative of 2x squared? 4x. So du equals 4x dx. Now, the original problem had x and a dx. No 4. That's okay. You can only do that for constants, numbers, not for variables. So for instance, you cannot put in, let's say, x squared here and 1 over x squared here. You're not allowed to do that. You can do that for numbers. So I put in a 4 outside 1/4. See, what we're doing is we're making the integral much easier. So instead of doing e to that mess, it's going to be e to the u. And then this thing that I have circled here, x dx and a 4, which is 4x dx. 4x dx, change it to du. Look at how much nicer the problem becomes. Instead of all of this mess, it's simply e to the u du. Once I get to this stage, it's pretty straightforward. So the integral of e to the u is e to the u. So I have 1/4 e to the u plus c. And then just change u back to what it was. It was 2x squared. So final answer is 1/4 e to the 2x squared plus a constant, c.
Professor,
Yes, question.
in our original problem, dx is in the exponent.
Dx should not be an exponent. No, it's not up
But
there.
in the book, it says it's in the exponent.
Right.
The book has it as an exponent, and maybe they wrote it wrong.
I don't know, maybe it's just my book.
It is
Number 10?
exponent. Yeah.
It doesn't look like it's,
Or yours is not, but ours is.
yours is
2x,
floating higher
2x
up.
to the power of 2 and then dx and then next to the power of 2. So
Okay,
it's an exponent.
So that's just incorrect.
Oh, your box is different. Yeah.
okay. So the dx shouldn't be floating up there. So whatever yours has, let's pretend the problem is the way I have it, because it should not be floating up that high.
Okay.
So
It should not.
maybe it's just a typo.
It should not be in the exponent, right?
It's not the exponent. Dx is never in the exponent.
Okay, that's just
Yeah.
a
So the dx is at the same level as e, let's say.
Thank you.
Okay, you're welcome.
Professor,
Yes.
before you move on the top in the beginning, in the original part, 2x squared up there, what's the 4 doing there? Or
This
is it?
right here is a u.
Oh, okay, sorry.
Yeah, that's a u.
Got it.
Yeah, I bet. I better just leave it alone. Okay. All right. 14. All right. So there's a couple of things about this game that you know. Okay. On the one hand, I know I don't like 4x to the 4th. I'd rather that be u. Okay. But also, as we mentioned last time, this is 4th degree. This is 3rd degree. So that works that way because you know when you take the derivative, when you differentiate something with x to the 4th, it's going to be something with x cubed. So that's perfect. Okay. So let u be 4x to the 4th, whose derivative is 16x cubed dx. Okay. The original has x cubed dx, no 16. So we know the way the game works. Put 16 here and 1 over 16 outside. Now I will substitute 16x cubed dx is du. And e to the 4x to the 4th is e to the u. Okay. One little complication here is that it's in the denominator. It has to be in the numerator. That's easy. Just bring it upstairs and make it 1/16 e to the negative u. Okay. Now, what's the derivative of e to the negative u? It would be e to the negative u times -1 by the chain rule. So when you integrate, I mean, you would say do the opposite, which is divide by -1. But if you divide by -1, it's the same thing as multiplying by -1. So in other words, the integral of this is still -1/16 e to the negative u. Okay. And then, yes, just change u back to what it was. U was 4x to the 4th. So final answer is -1/16 e to the negative 4x to the 4th plus a constant. Okay, and one more of this type before I do a few ln types is 16. Okay, yes, I realize I'm not doing all the problems. I'm giving you enough to get you started, and then Tuesday I'll probably do more. But I want to show you some of the ln type and show you some of 13.2 also. Okay, x cubed e to the, let's see. I'm sorry, x e to the 3x squared, that's right. Minus 5 over e to the x over 3. So they give me 2 integrals, so I decided to split it into 2, which you're allowed to do. So I break this up into x e to the 3x squared dx minus, okay, I bring this upstairs, so if I bring it upstairs, it'll be a negative, and treat x over 3 as e to the negative 1/3 x. Okay, so I call it I1 and I2. It's almost like I have to take a timeout, figure out I1, figure out I2, and then put them together. All right, so I work out I1, u equals 3x squared, du is 6x dx. The original did not have a 6, it has the x, it has a dx, it needs a 6. So put 6 and 1/6. So I now have 1/6. E to 3x squared is now e to the u. 6x dx combination, 6x dx is du. So I have 1/6 e to the u plus c1. Why am I writing c1? Because there's going to be a c2 here. I'm not allowed to put plus c and plus c here because that implies the two c's have to be equal. They do not have to be equal. So temporarily, I'm calling this one c1 and this one c2. But in the final answer, I'm going to write it just as c. Okay, then just change that back to e to the 3x squared plus c1. This one, okay, I'm going to try to share with you another technique that you can think in terms of the chain rule. It's kind of going backwards from the chain rule. You can do a u substitution, but I'll think of it this way. If I ask you for the derivative of just this, if you differentiate, you would multiply by an extra negative 1/3 by the chain rule. All right, keep that thought. Multiply by negative 1/3. So therefore, what happens when you integrate? Since integration and differentiation are opposite operations, instead of multiplying by negative 1/3, divide by negative 1/3. So you can always do that. Which means way back over here, you could have just simply said e to 2x divided by 2. as it is, or multiply by half. Okay, so if you differentiate, you would multiply by an extra 2 by the chain rule. So if you integrate, you would divide by 2 or multiply by half. Okay, so I'll employ that over here. Instead of multiplying by 1/3, I would divide by negative 1/3. And 5 divided by negative 1/3 is negative 15, because dividing by negative 1/3 is like multiplying by negative 3. So this is negative 15 e to the negative 1/3 x plus c2. All right, so I got my two integrals, I1 and I2. So finally, my original integral, which I decided to call I, is I1 minus I2. So I just put it together. I1 was this, minus I2, which is this. So 1/6 e to the x squared plus c1 plus 15 e to the negative 1/3 x plus c1 minus c2. But now you can put them together as just an arbitrary c. So this is now going to be my final answer for that one.
Professor Hong, can
Yes.
you go up a little bit? There's a red pen you're writing on the top in the beginning of this number. Okay, that's 6. And then inside there's another 6.
There's a 1/6 here and a 6 here.
Yeah. Is that, what is that 6 from?
Okay. So the original was just x, 3e to the 3x squared dx, right?
Mm-hmm.
So let u be 3x squared. The derivative is 6x dx. So same game. The original problem did not have a 6. I see the x, I see the dx, but I cannot change it to du unless there's a 6 there. So that's why I put a 6 inside and 1/6 outside. Same as all the other ones.
So if you put 6 there and then 1/6 over there, you multiply and then it will be 1, no?
Correct. That's the way it's supposed to be. You get an
So-
equivalent expression when you multiply by 1.
Okay, so, and then on the bottom you got 1/6 again.
Yeah, that 1/6 stays.
Okay,
I can't just throw it away. So the 1/6 stays. The 6 goes away because the 6x dx gets changed to du.
okay.
All the others were sort of like that also. Okay, now I'm going to move to the ln type of problem. I know there's more of the e stuff, okay, but I need to show you some of the ln and then show you some of 13.2.
Professor, can I ask a quick question about the
Okay, I have to get going with the others, so I can't take too many questions, but yeah, go ahead.
quick one? In the second line of this problem, and the second part, why did you change the exponent for e as minus 1/3 x?
Okay, so the e is in the bottom.
Uh-huh.
If it's in the bottom, bring it up as a negative exponent.
You switch the
Switch the sign. It's sort of like what I did over here. It's in the bottom, right? So I bring it upstairs and put a negative exponent. That's from
Oh.
algebra.
same thing as x over 3. Okay, I got it.
And x over 3 is 1/3, right? I wanted to coefficient.
Thank you.
Okay, now for some ln type problems. 18, you see, I don't see an ln. You're right, but it's going to become an ln. Okay, and again, I need to say my 18. I don't know if it's your 18, but whatever. Okay, but see, once again, what's the derivative of x to the 8th minus 1? 8x to the 7th. So that tells me how to substitute. So let u be x to the 8th minus 1. du is 8x to the 7th dx. So perfect. This becomes du. The bottom is u. So it says du over u, but you can pretend that's 1 over u. That's our natural log. Okay, so the integral of 1 over u du is our natural log. Okay, so if I can show you again in the text. Oh, where was it? Yeah, integral of 1 over x dx is natural log absolute value of x. Okay. So that's what I'm employing. So integral of du over u, or it can be 1 over u. You can always sneak in a 1 if you want. So that's ln absolute value of u plus c. And then just change u back to what it was. ln absolute value of 8x to the 8th minus 1 plus a constant. Okay. And problem 20 looks like this. And again, the tip-off is, again, this is degree 2, this is degree 1. So you know the derivative of this is going to be this or almost this. Okay, what's the derivative of y squared plus 1? 2y. There's a y. I don't have a 2, but we know what to do. So let u be y squared plus 1. du is 2y dy. So again, I cannot change to du unless I see a 2y dy. The original problem has y dy. It needs a 2. So 2 inside, 1/2 outside. And now I have what I want. So 2y dy is du. Y squared plus 1 is u. So there we go. So 1/2 du over u. And du over u is the same thing as what we had here. You can pretend there's a 1. So that's my natural log. Whenever you see a du over u or dx over x, you can pretend there's a 1 there. That's natural log. So 1/2 ln absolute value of u plus c. Change u back to what it was. It was y squared plus 1. 1/2 ln absolute value of y squared plus 1 plus c. Okay. There's actually one more tricky thing about this particular problem. Absolute value changes negatives to positives, right? But the expression y squared plus 1 is already positive. There's no way this is negative, right? If y is either a negative or a positive, when you square it, it's positive, and then if you add 1, it's positive. So in this instance, you can drop the bars. It becomes 1/2 ln parentheses y squared plus 1 plus c. Because y squared plus 1 is always positive. Okay? Now you might say, well, how come you didn't do that over here, right? Well, over here, x to the 8th minus 1 does have a possibility of being negative. I can think of a very easy example, that x be 0, right? If x is 0, then 0 minus 1 is negative, so you need to have the bars. Okay? But in this particular case, since I know y squared plus 1 is for sure always positive, I can just change it to parentheses. Okay. So that's the other extra trick about that one. Okay, 26 is likewise, and then that's the last one I was going to do for that section, and then I'll introduce some of 13.2 and show you what to do with that. Okay, 4x cubed plus 2x divided by x to the 4th plus x squared dx. Okay, so same trick. I see a 4 here and a 3 here. 2 here and an understood exponent of 1. So you know the derivative of this is probably either this or close to it. Because you know how to take a derivative, right? You always subtract 1. That's a 4, that's a 3, that's a 2, that's a 1. So let this be u. U equals x to the 4th plus x squared. What is the derivative of x to the 4th plus x squared? 4x cubed plus 2x dx. Perfect. That's the best case here. We don't have to multiply by anything. Like, oh, I didn't have to multiply by 2 or 1/2 or whatever. I just have it exactly the way I want it. So this is my du. This is my u. So I change it to the integral of du over u, which is the same thing as that one, which is the same as that one. So that's ln absolute value of u plus c. Change u back. ln absolute value of x to the 4th plus x squared plus c. Okay, and once again, like the previous problem, x to the 4th plus x squared, can that expression ever be negative? No, impossible for that to be negative, right? If you raise something to the 4th power, no longer negative. X squared, no longer negative. Add them together, it won't be negative. So just like the previous problem, switch it back to parentheses. Okay. All right, so I showed you 3 problems with ln. Okay, so hopefully you can get started with that. Now I'm going to sneak in some of 13.2 again, so at least you've seen 1 week in advance of the test instead of next Tuesday, 2 days in front of the test. So what is 13.2 about? You will notice something different right away. It looks like we're still doing integration, and we are, but now there are numbers here and here. They give me a number here and a number here. Okay, so let me jump all the way to 13.2 in the textbook. We're doing something called definite integrals in 13.2. Okay. A definite integral means there are definite numbers here. And if you stop and think about it, the opposite of definite is indefinite. So the integrals that we've been doing so far, all of the ones that we've been doing are called indefinite integrals. When you put a number here and here, it's called a definite integral. And the way I remember a definite integral is there are definite numbers. Okay, so if you look at the example that's right here, it's on my 797, whatever your page is, but it's the beginning of 13.2. So see, integral from 0 to 10. There's a 0 and a 10 of 100 e to the whatever dt. Okay, so how do I do that? Okay, so on my page 799, something called the fundamental theorem of calculus. Here's the way it works. How do I do integral from a to b of f of x dx? So you still integrate. You're going to plug in the upper number. They call it capital F of b, where capital F is antiderivative, minus f of a. So after you integrate, plug in the top number, plug in the bottom number, and subtract. Okay. Put this on your cheat sheet for sure. Okay. Integral from a to b of f of x dx is capital F of b minus capital F of a, where you integrate, anti-differentiate. You plug in the top number, plug in the bottom number, and subtract. Okay. It's on my page 799. Yours is probably close by, but this is it. Okay. Or we're recording, so you can always check the recording for this. Okay, so how do I do this definite integral? Okay, so I'll show you some examples. So 13.2. I need to label what problem this is. So integral from 0 to 1 of 8x dx. I think it's my problem number 2. Okay, so here's the way you do it. Integrate as normal, 8x squared over 2. You don't need a plus c. For definite integrals, don't need a plus c. Okay, now this funny looking s, 0 to 1, the proper way to write it is you move it to the right-hand side for some reason. It straightens out, and you put the 0 and the 1. Okay, so we have 4x squared, right? Difference is, don't need the plus c, just 4x squared. Double check, what's the derivative of 4x squared? 8x. Okay, from 0 to 1. Now, plug in 1, and then subtract whatever you get when you plug in 0. So I plug in 1, I get 4 times 1, which is 4. Plug in 0, you get 0. Answer is 4. Okay, so my final answer is 4. Geometrically, what does this represent? Okay, here's a quick graph of y equals 8x between 0 and 1. When I plug in 1, I get 8. Okay, what is the area of this triangle? Formula for area is 1/2 base times height. So it's 1/2 of 1 times 8, which is 4. Okay. When I do this definite integral, believe it or not, you get the area under the curve, bounded by the curve on the x-axis, going from 0 to 1. We won't prove it. We'll just state it. Okay. So it gives you an area. Okay. That's not technically 100% correct. Okay, but it's correct for most of the problems that we have to worry about right now. It's the area bounded by the graph and the x-axis. Okay, so what's the process? You integrate, don't need the plus c. The funny looking s moves to the right-hand side. It starts off on the left, it moves to the right. After you integrate, plug in the top number, plug in the bottom number, and subtract. So the answer is 4. I'll do a few more.
Sir, so in that example, why did you put it over 2?
What did I do what?
On that example, why did you put the 8x squared over 2?
8x squared over 2 is the integral of 8x. How do you integrate 8x to the 1? 8x squared over 2.
Okay,
like
I
before.
understand now.
Yeah, it's
Okay.
the same as before, except you don't need to put the plus c. Okay. I'll show you a couple more examples. Integral from 1 to 5 of 2 dy. Okay, what's the integral of 2? 2y. Yeah, the y here tells you what the variable is. Ordinarily, you would say 2x. If they put 2 dx, I would say 2x. If they put 2 dy, at least in my book, they put that. So that's why you have to put 2y. Doesn't really matter, though. Okay, the funny looking s straightens out 1 to 5. Okay. Now, plug in 5. 2 times 5 is 10. Minus, plug in 1. 2 times 1. So 10 minus 2 is 8. So the answer is 8. Geometrically, what does y equals 2 look like? Looks like a horizontal line. And if you're going from 1 to 5, okay, 1 to 5, I'm getting the area of this rectangle. What is the area of this rectangle? Well, if I go from 1 to 5, that's 4 units, right? So here in red, that's 4. The height is 2. So the area is 4 times 2, which is 8. Okay, so the integral, definite integral, gives you an area, which is actually quite amazing. All right. Number 6, integral from 0 to 5 of x squared dx. Okay, this is a definite integral. So definite integrals, you don't need a plus c. Indefinite integrals, you need the plus c. So what are indefinite integrals? That's if it's like this. It just says integral of x squared dx, right? Then I would give my answer as x cubed over 3 plus c and stop. For a definite integral, the answer is a real number. As you can see here, the answer is going to be a real number. So I still integrate x cubed over 3, don't need the plus c, from 0 to 5. Okay, plug in 5. 5 cubed, 5 times 5 times 5 is 125 over 3. Minus, plug in 0, you get 0, right? 0 cubed is 0, 0 divided by 3 is 0. So 125 over 3. Okay. This is the answer. What does that 125 over 3 represent? Okay, now y equals x squared is a parabola, looks like that, between 0 and 5. That's the area right here. Underneath the curve, y equals x squared, going from 0 to 5, that's 125 over 3, which is 40 something, 41 and 2/3 or whatever. Okay, that turns out to be the area there. Okay, so it's quite remarkable that we can actually find areas by using this integration stuff. Okay, do just a few more and then I'll stop. Okay, 10, integral from -1 to 4 of 6x minus 9 dx. All right, so the -1 and 4 starts off on the left side. By convention, it moves to the right and straightens out. So -1 to 4. Integral of 6x, 6x squared over 2. Integral of -9, -9x. And of course, this becomes 3x squared. 3x squared minus 9x. Remember, how can you double check your integration? Differentiate. What's the derivative of this? The derivative of 3x squared? 6x. Derivative of -9x? -9. That tells you that you did it correctly. Okay, and this is a little bit harder. So parentheses, parentheses, plug in 4. Minus, parentheses, parentheses, plug in -1. Okay, so 4 squared is 16, right? So it's 3 times 16. 3 times 16 minus 9 times 4 is 36. So 3 times 16 minus 36 minus parentheses, plug in negative 1. Negative 1 squared, 1 times 3 is 3. Plug in negative 1 here. Negative 9 times negative 1 is positive 9. Okay, and if you can't see that here, that's 48. 3 times 16 is 48. So I have 48 minus 36, 12, minus 3 plus 9 is 12, 0. The answer is 0. Okay, that's it for the problem. The problem's actually finished, but what's the interpretation of area? So this is getting more deep than we really care to. If I draw the graph, it looks like this. Okay, it turns out when I said you get an area, it's not quite true. You actually have a signed area, S-I-G-N-E-D. You don't have to write this down because I'm not really testing you on this. But officially, when you do an integral, anything above the x-axis is counted as positive. Anything below the x-axis is counted as negative. Okay, if you calculated this area and this area, they would match, which therefore means the integral is 0, because you would have just as much area below the x-axis as above the x-axis. Okay, if you don't understand that at all, don't worry about it. Okay, all I want you to do is know how to do these integrals. So if you went from here to the final answer of 0, that's all you need to know for the test. Okay.
Why do you
go straight to that?
15?
I'm sorry?
Why do you have the number 15?
15. This is 4 comma 15. The height is 15. You would
Okay.
plug in 4. So if you do 1/2 base times height and 1/2, and this is negative 15. If you plug in negative 1, evidently you get negative 15. Okay. So if you want to do 1/2 base times height, and that's where that 15 comes in also. Okay.
And that 15 came from the original problem, right? Which is a 6 times 4, 24 minus 9.
Minus 9 is 15, right. Okay. I put the 15 to show that 1/2 base times height here is exactly matches 1/2 base times height here. You go up 15 here, you go down 15 here, and these distances will match also. I don't know what they are exactly, but you could work it out. And it turns out this area matches that area. So the net result turns out to be 0.
Professor Holm, do you require us to make a diagram also?
No, this is extra. You don't need a diagram. This is all extra. It's for teaching purposes. But what do you need to know on the test? Go from here to 0 and stop. And that's it. Okay. I'm just showing you what's so good about having this stuff. Okay. In fact, the next one, I don't have a diagram. Okay. I don't want to graph that, right? But we don't need to know. Okay. Integral from 2 to 4 of 3 radical x. So that's x to the 1/2, right? Square root means x to the 1/2. So 3 x to the 3/2, 1 more than 1/2 is 3 over 2. Divided by 3/2 means times 2/3. And these cancel out. So I have a 2 in front. You're allowed to factor out the 2. 4 to the 3/2 minus 2 to the 3/2. Okay, how do I do this? Okay, the 2 means the root. 3 means the power. So square root of 4, 2. 2 cubed, 8. This one's not going to be nice. But I can write it like this. 2 to the 1 times 2 to the 1/2. 1 plus 1/2 is 1.5, 3/2. The reason why I do that is I can write it as 2 square root of 2. This is the best way to write the answer. So 2 times 8 minus 2 radical 2. Okay, so one more time. 2 to the 3/2. Think of it as 2 to the 1 times 2 to the 1/2. 1.5. That way I can write this as just 2 and that's square root of 2. So final answer 2 times 8 minus 2 radical 2. So for this graph, which I'm not going to write this time, but I did it for the other examples, whatever this graph looks like between 2 and 4, that's the area. Okay, one more and then I'll stop and give you the quiz. So again, I haven't done a complete job with either 12.3 or 13.2, but some of you, hopefully you saw enough that you can get going with all of it. And then Tuesday, I'll pick up the leftover pieces and go back and finish the rest of the problems, okay?
Professor.
Okay, yes.
Okay, on the number 14. Okay, so you plug it in 4 and 2 also in this parenthesis.
Yes,
So
4 right there and a 2 right there.
okay.
That's the way it works. Okay, x plus 2 to the 13th. Now, I could do a u substitution, but I don't have to because the derivative of x plus 2 is 1. So it doesn't cause me any concern when I integrate. So I'll just go straight to the power root. X plus 2 to the 14th over 14 from -1 to 0. Okay. Now, I couldn't do that if this was x squared. I would have issues. In fact, if this were x squared, frankly, the only way to do it is to multiply that out, which I will not make you do. That's bordering on torture to make you multiply that out. But since the derivative of x plus 2 is 1, no issues with the chain rule. Just go right to this. You can check by taking the derivative. What's the derivative of this thing? 14 comes down, knocks out the 14, x plus 2 to the 13th, and then by the chain rule times the derivative of the inside. But that's just 1. So it's good. It would not be that nice, though, if this were like x squared. So anyway, let's finish this. Plug in 0, 2 to the 14th over 14, minus, plug in -1. -1 plus 2 is 1. And 1 to the 14th power is still 1. And I have a common denominator, so the final answer, 2 to the 14th power minus 1. That's a 14 there. Okay, you can punch it in your calculator. 16,383 over 14. Final answer. Okay. Okay, so I have shown you enough of 12.3 and 13.2 that I think you can do the rest of the problems, but if not, I'll complete it on Tuesday. But again, I wanted to be sure I showed you some of 12.3 and some of 13.2. So again, it wouldn't be, I wait until Tuesday to show you 13.2 and then you only have 2 days to learn it. Now you've seen everything that you need. So now at least you have 7 days to prepare for the exam next Thursday, okay? So that is that. All right, let me check the chat real quickly if anybody has a question. Otherwise, I'm going to go straight to the quiz. Okay, so Jonathan shared. Thank you again, Jonathan. So there we go. All right, so quiz time. So get out your cell phones and cameras, and I'll set up the breakout rooms. As usual, do Tuesday. So Tuesday, I'm just going to do more of this and more of this, and then next Thursday's a test, okay? All right, so here we go. Hopefully it's not too bad.
It seemed like there was someone with a question on the chat.
Okay, I'll have to, I'm already here, so let me go straight to this. I'll worry about that later. Okay, so integral of 3x squared plus 4x minus 5 dx. And integral of x cubed minus 4x squared plus 7x to the 5th power times 3x squared minus 8x plus 7 dx. Okay, and I'm afraid since I've already started this, I'm not going to answer any question from the chat. I won't be able to. So sorry about that. You can send me an email or ask me on Tuesday. Okay, I'm going to make this disappear in a couple of seconds. So hopefully everybody has it. We're still recording. Should be straightforward, and do Tuesday. Okay, so that's that. Let me stop the share. Set up your breakout rooms.
Before you stop recording, maybe while we're in our breakout rooms, you can just do it and then post it on with the video so that they can have it.
But I think the question that was asked was involving question 14, which I've already done. So
Oh, okay.
I
Okay.
won't have time to do that, unfortunately. Okay, so recording is stopped.